In this unit, I would like to talk about the ellipsoidal reflector spot, or essentially the backbone of lighting in the theater, right? Ellipsoidal reflector, or ERS, is named obviously for its reflector, right? And the shape of an ellipse as a reflector converges all of the light rays to a specific point, a focal point, as opposed to a parabola that moves all of the light waves in one direction. An ellipse is designed specifically to converge all of the energy to a very specific point, and that focal point is the gate, right? It's the focal point, the gate, it's where the shutters are, and it's where gobos are placed in this focal point where all of the light rays converge. From there, they cross each other and expand again until they encounter the lenses, and the lenses are what focus the beam of light as it moves forward. So in ERS, you can slide the lenses back and forth a little bit to sharpen or soften the image a little bit. You can't really change the size, or you only change the size just by a small margin. But you're softening or sharpening the image, right? In order to change the size, you need to swap out the lens tube. This lens assembly, you can unscrew the little knob at the bottom and exchange these lenses, and you can get different sizes by exchanging these lens tubes. An ERS, as we had mentioned, has shutters in which shape the image, and a pattern slot or a gobo slot where we can insert stenciled patterns and project them with the light. Now let's look a little bit about this beam angle and beam spread. Every fixture has a beam angle and a field angle. The beam angle is measured by 100% intensity of the light output, and the field angle is the area to the edge where the light starts to fall off, even if the image is absolutely razor sharp and crisp. There is still a hot spot in the middle surrounded by an area of lesser intensity. So the beam angle and the field angle, right? So a source 4 comes in a variety of lens sizes, from a 90 degree to a 5 degree. The bigger the degree number, a 90 degree, the wider the angle. So this is an 80 degree cone, a 55 degree, and you can see as the numbers get smaller, the beam gets smaller, right? The same with these. A 50 degree is wider than a 10 degree. And the smaller the degree number, the better it is at throwing light really long distances, right? So you can see that a 5 degree is easily good to throw light 80, 90 feet and still have a small pool of light. Whereas a 50 degree is going to throw light 10 feet, and at 10 feet, it's going to make about a 10-foot pool of light. If I tried to use a 50-degree lens to light something 50 feet away, I'm going to have a 50-foot circle of light. Number one, is not going to be very bright, and number two, it's just too big to be useful. We want to control and select our beam size. Let's see what the fixtures look like. This is sort of what a 5 degree. It's really large. It's a 14-inch aperture. It's got a huge lens on the front. The lens has actually been cut like a Fresnel lens, and it's made out of plastic to try and reduce weight, right? Here is a 10 degree, a 14 degree, and all of these are examples of 26, 36, 19, right? These are sort of the common workhorses. And then the shorter ones with the wider apertures might be like a 70 degree or a 90 degree, right? So smaller the number, right, is the tighter the beam angle, and oftentimes the larger the lens, right? So, but the big thing to remember is that the bigger the degree number is, the bigger the pool of light, right? So we've been talking about shutters, how the shutters work. If you're standing behind the fixture, there's a left and a right and a top and a bottom shutter, right? And by pushing in the right shutter, you make a line on the left side of the image. If I push in the top shutter, I make a line on the bottom, and I can angle that shutter to angle that cut. We can do very, very precise trimming of the light coming out of an ERS to make very specific shapes. Pressing in the left and the right shutters can make an alley of light or a column of light, and pushing in all four can change it into a square. Let's see what this looks like a little bit. In this image over here, we can see that this light has been doesn't have any shutter cuts, but it's been focused to be a very sharp pool of light. The edges are very clearly defined where there is light and where there is an absence of light. If we look at some of the other specials that are around, you'll see that they have actually had shutter cuts pushed into them to make them more into a square. They've also had the lenses adjusted a little bit so that they're slightly softer. These pools of light are not nearly as crisp as this. You can see here's a pool of light where the edge is just what I call broken, right? So it's not razor sharp like this. It's softened just a little bit. And here's one that's even softer still. I am positive that these are ERS. These are spotlights that are focused onto a very specific target, right? And then softened a little bit so that they don't have a sharp edge. You can see our hot spot here, right? And then how this trails off into our field angle where it's just a little softer and moves off to the edge. Here, let's look at our next one, right? So talking about application, oftentimes we want more control over the stage. We want areas of light that we can turn on or off, and an ellipsoidal is perfect for that because it's, number one, shooting a long distance from front of house. It has shutters that we can control the edges, and then we can soften the edge. And by overlapping these, we create areas of light that then we can control. If I wanted to focus just on our two performers in the middle, I could turn off the sides and just have them focus in the middle. And they overlap so that as people move left to right, they don't walk through bright spots and dark spots. And so that is an application, and we'll be back with a little more in just a minute.